All right, welcome to Chapter 8, Section 5, called Rhombi and Squares. This is for Integrated Math 1 Integrated Math 2 or IM2. So the first couple things you'll see on your screen here, the first thing should be a due date. I don't see that on my teacher preview, but you'll see it on your student screen. The second thing is the unlimited attempts, or the number of attempts. You always have unlimited attempts on homework, quizzes, and tests. Number of questions just tells you how many are on this particular assignment. Grading policy is always best score. Whichever attempt is the best one is the one you keep. And partial credit is enabled, so if you answer 1 of 3 questions correctly, you get credit for one question, or however many you answered correctly. Down here it says, please remember once you start your homework, you must finish before you can work on anything else. What that means is once I click start, down in the bottom right corner on your student side, you will see a submit assignment button. I don't see that on the teacher preview, but you will see it on your student screen. I just noticed that this is not the correct assignment, so I will go through and change that, but we'll go through these first, and then I'll go through and fix that really quick. So we want to click the Submit Assignment button because it does 2 big things. Number 1, as it said on the last screen, you can't work on anything else until you click that button. That's how you finish your assignments. So if you just close this tab, if you're ready to leave and you just close this, or you close your computer, Alex is going to assume you want to leave this attempt open, and it will freeze all of your other assignments and resources. So you need to make sure that you click Submit Assignment. It'll save your place. Whatever you've worked on, it will save, and then you can come right back and try again, because remember, you have unlimited retakes or unlimited attempts. The other thing that it does is it affects the grade book when you click Submit Assignment, so your teacher can actually see what you've been working on. Until you click that button, your account's basically frozen. So good habit, always click Submit Assignment. Explanation, example, and message center are always on the side here. Explanation tells you you're going to lose your question attempt because it's going to give you the answer to this question. Example, it will go through, it'll show you an example of what we're looking at. And remember, this is not quite the right question. I'll fix that in just a second. So we want to make sure that we read through, we understand exactly what it wants us to do in the example, and then we can close this. We can open another example if we want to see one. We can also message our teacher directly from this screen. And it sends a picture of the question you're working on so that your teacher can help you work on it. Okay, so now that's corrected. They are the correct questions, and there are 6 of them instead of just 3. I must have forgotten to save it when I was updating this assignment. All right, so we're going to look at a Venn diagram real quick just to compare information. This is going to come in handy when we start to look at the differences between just parallelograms and special parallelograms. So it's just the idea of where do these groupings kind of fit. So Venn diagram is just a very quick little reminder, visual of how we can group things. So with this one, it says the Venn diagram shows the memberships for softball club and tennis club. So we have softball, we have tennis club, and then we have this overlapping section in the middle. So in the middle, it means that they're both in softball and tennis club. They're in both. So how many people play softball? And we're going to ignore the fact that it said club and now it says play. We're just going to assume if they're in the club that they play. So how many people play softball? That's the entire circle for softball. So we have 1, 2, 3, 4, 5, 6, 7. 7 people play softball. How many people play tennis but not softball? So now we have tennis over here. There's 3 that play tennis, but we don't want the ones that play softball. Only the ones that play tennis. So that's only 1. And how many people play both softball and tennis? So that's where they overlap in the middle here. So we have 2. All right, so that's just kind of a reminder, how Venn diagrams work. It's just comparing information. All right, so this one says answer the questions about the figures below. And with this one, we have parallelograms, rectangles, and rhombi. Or squares, actually, just squares. It doesn't say rhombi on the description. So we can see parallelograms, rectangles, squares. And that's actually what this title is called, identifying those 3 things. So which figures are parallelograms? So remember, and I can even open this real quick, because I have this guy here. There we go. So this was from a couple sections ago when I wrote this up. So all of these things come from the word parallelogram. If I know it's a parallelogram, I know all of these markings are true, which is opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, The diagonals bisect each other. Consecutive angles are supplementary, which means they add up to 180. There's all kinds of things that come with the word parallelogram. To prove that it's a parallelogram, I can use one of these 5 pieces here. So opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, the diagonals bisect each other, or we have one side that's congruent and parallel. So it has to be the same side. It could have also been the left and right side. I just drew the diagram top to bottom on this one. So we just want to look at this one and take a look and say, okay, well, number 1, it needs to be quadrilateral. It needs to have 4 sides. That's the main definition of parallelogram. It's a 4-sided figure that has one of these properties. The definition is a 4-sided or quadrilateral that has opposite sides parallel, but we can prove one of these other pieces. So this is 4-sided, and opposite sides are congruent. So figure A works as a parallelogram. If I look at figure B, I can see that we're not going to have opposite sides parallel here. That's not going to work. And the opposite sides are not what we would call congruent, because 4 and 2 doesn't work. 4 and 2 doesn't work like this. So that's not going to be a parallelogram. On this one, we do have a 4-sided figure again, and opposite sides again are congruent. So figure C also works. If you notice, I can click more than one. I can see that there are these little square features, which means I can click more than one. If they were circles, that would mean I would click a single one. All right, so which figures are rectangles? So remember, rectangles are special parallelograms that have right angles, so all 4 right angles. And the other bit, the bit that's special about rectangles, which doesn't come up in this diagram, but I've seen it in other diagrams, is that the diagonals are not only bisecting each other, but they are congruent in a rectangle. So if we have 4 right angles on a parallelogram, I already know it's a parallelogram, and I have 4 right angles, that is a rectangle. I don't have right angles on the other 2, so those will not be rectangles. Squares, well, I can kind of obviously see none of these are squares. A square has the same properties as a rectangle, except it also has congruent sides. So it's kind of a step down. So parallelogram goes to rectangle, rectangle can go to square. So we can say that a square is a rectangle, but we cannot say a rectangle is a square. We can't, because a rectangle doesn't have all 4 sides congruent. We have 2 long sides and 2 short sides. So we would say none of these figures work for a square. So this is what we call a kite. If that, I believe that comes up in a little while. A kite has consecutive sides that are congruent. So 4 and 4 and then 2 and 2, like that. And it has some other properties that go with it as well. But we call this one a kite, not a rhombus. A rhombus, square is a rhombus, where all 4 sides are congruent, and it is a parallelogram. A rhombi is just another special parallelogram. Okay. Did they give us? They do. Okay, so this is the diagram that I have on the notes page, and I really like this one because it kind of shows you the progression, or like the flow chart for these ones. So we have quadrilaterals. A trapezoid is a quadrilateral. It's a 4-sided figure, but only one pair of opposite sides is congruent in a trapezoid. So a lot of the time it's drawn like this, where you can see top and bottom are congruent, or not congruent, sorry, but parallel. These do look congruent on the side, but that's not a requirement. I could have drawn this side straight down. It could be a right angle here, and it would still be called a trapezoid. As long as one pair of sides is parallel, it's a trapezoid. And then parallelogram. So the basic idea is we have 2 pairs of parallel sides. And then we go into the special idea of rectangle or rhombus. So rectangle has 2 pair of parallel sides, just like a parallelogram, but it also has 4 right angles. A rhombus has 2 pair of parallel sides, just like a parallelogram, because it is a parallelogram, but now it has all congruent sides. So that's what's special about it. And then these both drop down into square, because a square has 4 right angles and all sides congruent. So a square is a rectangle and a rhombus. It's both, but we can't say a rectangle is a square. We can't say a rhombus is a rectangle in any way. That's not how they work. It kind of flows down to the square. So square is both of these, but these 2 are not both each other. Hopefully that makes sense. And not all rhombus or rhombi are squares. Sometimes they're kind of diamond looking like this one. Okay, so now we're going to go through and we're going to use these facts to fill in that chart. So all sides are congruent. For a parallelogram, that's not always true. So remember, you want to make sure that it has to be always true. It can be true, but it's not always true. 2 pair of parallel sides, that's true for a parallelogram, a rectangle, and a rhombus. All 3 of them have to have those 2 pairs of parallel sides because they're all parallelograms. 1 pair of parallel sides, that would only work if you saw trapezoid. I don't see trapezoid there. So the all sides congruent, that fit into the rhombus category. So this, I'm not going to click any. And then all, or 4 right angles. So the only one that would fit here would be rectangle. If I saw square, I would also click square. Alrighty. So I'm going to go ahead and cancel. I just want a new one. I don't want to close it. Alright. So for the rhombus below, find the measure of angle 1, 2, 3, and 4. So we have a rhombus. We don't necessarily know that it's a square, but we do know that it has some special qualities to it here. 1, 4, and 3. So we're given that this angle here is 44 degrees. Remember, if it says rhombus, I know that everything before that was true. And what I mean by before that is if I was looking at that diagram again, everything that's true for a parallelogram is true for a rhombus. A rhombus also has congruent sides all the way around. This one looks somewhat square, but we're not going to necessarily, promise that it's a square. All right. So with this one, we have, for this piece, let's see, we're going to go down and we're going to fill this piece in. So the other bit for a rhombus, which I'm going to go ahead and click on the example because it does tell us this in the example. The background here is it's a parallelogram of 4 congruent sides. We know that. And this one even looks like a little bit more of a squished diamond. So the diagonals of rhombus are perpendicular. So that's another bit that we can kind of use here. Let's see. They bisect each vertex angle. So that's another very important piece. The diagonals of a rhombus also bisect the vertex angle. So if I know what 1 is, if it bisects it, the other side has to be the exact same thing, like that. And remember, opposite angles are congruent, so it's going to be the same, because this is a isosceles triangle. So I'm using that idea again of an isosceles triangle. I think we either use that on this video or the very last video. I can't remember. There's a couple very similar ideas we're using here over and over again. So because this angle is 44, so is this angle. So I've already filled in these 2. I could have also used alternate exterior or interior angles here because I have parallel to a transversal, parallel to a transversal. So I know that they're both 44. And then to fill this piece in for the 3 here, I could either use consecutive angles add up to 180 or triangle angle sum theorem because I have 44, 44, and then a missing angle. And they have to add up to 180 degrees, all 3 of them. So I have 88 here, and so I can say, well, what have I used? I've used 88, so I'm just going to subtract, and let's see, that would be 92, right? So angle 3 here has to be 92 degrees. So just going through and understanding some of those pieces. So that diagram didn't quite show us the diagonals for a rhombus are a little bit more special where they bisect that angle. So that definitely changes things up a little bit. Oh, and I forgot angle 1. So angle 1, that's opposite of angle 3, so it's also going to be 92 degrees. So I have 92. Angle 2 was 44. Angle 3 was 92. And angle 4 was 44. All right. Check. Perfect. Okay. So this is just going through and kind of determining whether or not or what we would classify these as, not necessarily whether or not they are something, but we're given the markings, and we have to determine, is it a parallelogram, is it a quadrilateral, is it a rectangle? So remember, if I can prove that it's a rectangle, then it is a parallelogram and it is a quadrilateral. If it's a four-sided figure, regardless of anything else, then it's automatically a quadrilateral. All three of these are a four-sided figure. They're all quadrilaterals immediately. Now I'm going to go through and determine, is it a parallelogram? So a parallelogram, and we have, I'll open that back up again, this guy here. I can use any of those properties to prove this parallelogram. So I have opposite angles are congruent here. I know that's parallelogram. That's as far as I can go. I can't prove that these are right angles. I don't know anything about the diagonals here, so I can't say it's a rectangle. It looks like a rectangle, but I can't prove it with the markings. So don't use, oh, I can see that it's a rectangle. Make sure you can prove it with the markings. On this one, I have a pair of parallel lines and one right angle. Well, if this parallel line is perpendicular to the transversal, the other one is also perpendicular to the transversal. And then let's see, we don't necessarily know anything about this side. I don't think we can prove, I'm trying to remember off the top of my head, there's nothing I can think of really quick that I could prove. It looks like a right angle, but I don't think we can prove that it's parallelogram just with those two pieces. We would need to know something about these angles over here. I could be wrong about that guy, but I'm going to say that we can only say it's a parallelogram for that one. For this one, I can see that these three are congruent, and this is a right angle. I don't have any other markings for it, though. I don't necessarily know if this is going to be congruent across. If we knew that it was congruent across, then that would actually change things, because then they'd all be right angles, and I could say it was a rectangle and also a parallelogram. The only thing I know these are congruent, but I don't know anything. I don't know if these opposites are congruent. It doesn't necessarily tell me that. So I'm going to say, again, I can only go quadrilateral. Let's check and see. So which one does it not like? These are the conditions for a parallelogram. See, this is the one that I was picturing, but we can see that both pairs of opposite sides are parallelogram, and we only need the one right angle once we know that, because opposite angles are congruent, consecutive angles add up to 180 degrees. So they do actually have that diagram in there. So it is a quadrilateral with at least one right angle and all other angles congruent to each other. So they do actually have that in the diagram. So let's see. If we know that it's 90, and then 3x, because we would subtract the 90, it would be 260 or 270, and if we divide by 3, we get all four 90s. Tricky. I didn't even think about working it out there. So all of these would end up being 90-degree angles, so it is a parallelogram, and it is also a rectangle. All right, so no, it wasn't that one. I was thinking maybe because of that right angle, but because I don't know that these are parallel, it's not giving me any markings. That's why I didn't do anything with it on that one. All right, let's keep going. Okay, so with this guy, we are going to be classifying parallelograms in a coordinate plane. So we're considering a parallelogram. We already know it's a parallelogram. It's already telling us that. So I'm going to go ahead and just get a new one here. Boom. Okay. So it tells us we have JKLM here, and it gives us the vertices. Answer the following to determine if a parallelogram is a rectangle, rhombus, square, or none of these. Well, it told us it's a parallelogram, right? We already know that. So if the parallelogram is either a rectangle, a rhombus, or square, so we have to think about those pieces. For a rectangle, oops, why is it? Oh, because I don't have my pen on. For a rectangle, I would need to show, we already know it's a parallelogram, so all of those apply, but I would need to show that we have right angles like this. I could also show that the diagonals were congruent. That would make it a rectangle, and it would also qualify as a square if all four sides are congruent. We'd have to go a little farther to determine if it's a rhombus, and then a square. So what it's going to have us do first is find the length of LM. So in order to do length, we need the distance formula again. We were doing this a little bit ago. I think it was on my last video, actually. So this guy should be on your notes pages. It's the distance formula. So we subtract the x's, we subtract the y's, we square those, add them together, and then take the square root. This actually comes directly from Pythagorean theorem, where we have a squared plus b squared equals c squared. So if I could actually draw down and over, so this right angle here, I would have a, b, and c. C is actually the length of jm. I know I didn't draw that perfect on here as far as the diagonal, the direction there, but it's just the picture. So I'd have a squared plus b squared. Well, a squared is the difference in y, right, the change in y. B is the change in x, because it's left or right. And then c, that's the distance we're looking for, so that's why it's d. But instead of d squared, what we're doing is we're taking the square root of the other side, so I just have d on this side. So it's just a little background. Where does the distance formula come from? It's Pythagorean theorem. All right, so we're going to go LM. So L is 7, negative 2. M is 5, negative 5. And we have, remember it's x, y, and it's 1, 1, x, y, 2, 2, and this just means 0.1, 0.2. So I have 5 minus 7 squared plus negative 5 minus negative 2. Make sure you leave this minus. It's part of the equation here, so that doesn't go away. So now I have 5 minus 7, that's negative 2, plus negative 5 plus 2. Minus negative turns into a plus. So I end up with negative 3. So now I have 4 plus 9. That gives me 13. So I come over here and I'm going to go square root 13. And now I'm going to find the side length, the length of a side adjacent to LM. So for LM, they don't care if it's JM or KL. You get to choose. It just set a side adjacent to it, meaning right next to it. So they don't want the opposite side. They want a side right next to it. What we're doing is we're testing, are the consecutive sides congruent? If the consecutive sides were congruent, which I can kind of obviously see that they're not, but if they were, that means that it would go into a rhombus. If we already have a parallelogram and consecutive sides are congruent, it is a rhombus. So we're just checking that real quick. So I know it's not going to work out correctly, but I have to fill this in. Alex is going to require it. So let's see, J, and I just picked JM for this one. It wouldn't matter which one you did. If you did JM or the top one, which is KL. Negative 1, M is, so that's, I wrote that in the wrong spot. Scribbled that out, but that was me writing it in the wrong spot. That was supposed to be there. Negative 1, and then M, 5, negative 5. All right, so I have 5 minus negative 5 plus negative 5 minus negative 1. I think I said minus negative 5, minus negative 1. I wrote it correctly anyway. All right. Both of these turn into plus signs. So I have 6 squared plus negative 4 squared. So I end up with 36 plus 16. So let's see, I end up with 12, 4, 5, 6, so 62. And I can't take any square roots out of that because it can divide by 2, but that would give me 31, so that doesn't help me at all. Oops, 62, not 32. So they're obviously not congruent. So it's not a rhombus, which means it's not a rectangle. But we can still see if it is a rectangle other than, rhombus or square. We can check the slopes. So we want to check the slopes because we learned this. I actually think it might have been back in semester 1, if a line is perpendicular to another one, the slopes are going to be negative reciprocals. And what that means is if the slope of one is 2/3, the negative reciprocal, I would flip it over, and if it's positive, it becomes negative. If it was negative, this would become positive. That's all negative reciprocal means. We flip it over and we flip the sign. Okay, so we're going to check to see if that works. So slope is rise over run. So this is still the difference in y's, and it's the difference in x's, but we're just doing a division, a ratio here. All right, so we're going to have LM. So L was 7, -2, and M was 5, -5. And so we have y minus y over, sorry, minus, it was minus negative because it's the two negatives, and then 5 minus 7. So I end up with -3 over -2. Well, the two negatives are going to drop away. It's just going to be 3 over 2. That was actually a guess. I didn't mean to do the 3 over 2. I was just kind of guessing there. That's very silly. I did not mean to guess that slope there. All right, and then it says a side adjacent to LM. So let's go ahead and stick with JM here. Why not? So J is -1, -1. M was 5, -5. Like that. All right. So now we're going to have y minus y over x minus x. So I'm going to have plus and plus. So I end up with -4 over +6. I do need to reduce this. It's going to stay negative because there's only one negative this time. But I can divide by 2 and I get 2. I can divide by 2 and I get 3. So I have these two pieces. So 3/2, 2/3, that's a reciprocal. I flipped it over. This was positive, this was negative. So just by chance, I kind of guessed at the fact that it was going to be 2 and 3. Oops. There we go. Hit too many times. So, don't click on that one. So because the slopes are negative reciprocals, LM is perpendicular to JM, which means this is a right angle. If I have a single right angle inside of a parallelogram, they are all right angles. And why is that true? Well, because if we think about a parallelogram, and that's a very horrible parallelogram. Goodness gracious, I can't do a parallelogram right now. Better. All right, so if we have this one angle here, that's a right angle, remember all the other pieces still work for this because it's a parallelogram. So opposite angles are congruent. So this is a right angle. Consecutive angles add up to 180. So that would be 90 and 90. These are also consecutive angles or opposite. So 90. So if I have a single 90-degree angle on a parallelogram, they are all 90s, which is the definition of a rectangle. I have to have 4 right angles. All right. Uh-oh. Which one did it not like? 5. Oh, it's 52. Silly me. That was silly. 52, not 62. Okay. It just didn't like my addition there. Do mistakes happen? Of course they do. Just go back, check your answers. I knew it's important to know that these aren't equal. It's not 100% important to know the exact answer. As long as I know that they're not equal to each other, then I know they're not rhombus or square. That's what we're checking for. But Alex wants me to make sure I did my math correctly. It wants me to type that in to show that, that I've proved that it's not a rhombus or a square. All right, so that was section 5. I will see you in section 6.